what we do initially is that you're going to hydrate your sample. No, just for demonstration purposes, I just have 500 milliliter, and this is about a teaspoon or 2 teaspoons, okay? The instructions in the actual the cans will have measurements in terms of how much water you want, with respect to how much of the rice that you want in terms of concentration for feeding, okay? Now, what you're going to do first is that you're going to add your rice to water, and this is in order to hydrate it. You're hearing me again? In order to hydrate it. So, usually it will be between 10 minutes to half an hour of hydration. They want to have that they're completed yesterday was actually overnight and everything. Now, first I have this, it's in a suspension. So this is brine shrimp, dried brine shrimp in the water. And the first thing that I'm going to do is that I'm going to strain it and rinse it under running water. Okay? So you're going to just thoroughly rinse it. Decant this into a beaker of full strength Clorox of bleach. Okay, so let me just come around then. So they use Clorox down here. This is the Clorox. Now please know that this is actually an exothermic reaction. So it will produce heat. So what you're going to need to do as you have that is that you're going to have a thermometer in order to monitor the temperature. Once it exceeds 35, that can actually kill the eggs. So we will try to have ice available or on hand in order to add it to the reaction to make sure that it does not exceed 35. Okay, if it does exceed 35, add ice. Once you're below, you should be fine. Okay.
What happens over 35 degrees Celsius?
Right? Now, the reason why I added this to bleach is that we want to decapsulate or remove the outer layer, the chitinous layer of the egg itself. Okay? So, the reason why we added to bleach is in order to remove the outer chitinous layer from the eggs. Now, it's an oxidation reaction, so it oxidizes the outer layer and dissolves it. Now, so far the temperature is about 20. That's probably because the lab itself is of a low temperature, and you might not see the change in this, but when the oxidation takes place, the eggs will change from a brown color to an orange color. The orange color is an indication that the outer chitinous layer has been dissolved, and when we see that change, then we know that we can actually remove the bleach. We have to rinse some of the bleach as well. Okay? Any questions so far? Now, one thing to note when you're doing this procedure is you try to keep your suspensions agitated. So you need to constantly stir it. If you have aeration available, you can add aeration to it. So, for example, if I was working somewhere and I had to hatch brine shrimp to feed larval organisms, for example, tilapia or shrimp larvae, I would actually use an aeration. So you can have an air pump available and aeration and continuously mix it. Right? So you may not see the change, but it actually has lightened a bit in color. And once you do this and you see that change, so you try to get a thorough change throughout and almost all or as much as possible of the brine shrimp themselves, right? The brine shrimp eggs. Okay, so my next step is that I need to rinse these. Okay, so I'm going back to the sink and I'm using my brine shrimp net again. So again, thoroughly rinsing. Right, and I can actually see color change, that they are more orange than brown now. Now you rinse as much as you can until you get the center of the bleach out at least, so you know that there isn't any bleach because that can kill them. Alright, and then I'm going to turn this into another beaker of clean water. Questions so far? Now, the sample that we had, our end product, is going to be what we have here, being bubbled. That's the brine shrimp that is hatched right now. So there are some that are still eggs. They're decapsulated, but they're in the process of hatching, and then we have the hatched ones. Okay? So if you look at this, you can pass it around, you'll see the color change. It's now orange. Anybody else not seeing it? So there is an orange color change. So what we do is that we're going to leave this aerated, and it's going to hatch overnight if possible to get a maximum output. Okay? So I will add more brine shrimp, and it will look like this. It's a larger quantity you tend to need in order to feed, especially in agriculture. Okay, because they have a lot of increasing number of the larvae. Okay, so and that's a question. So remember, you have to hydrate it first, rinse, add your bleach in order to decapsulate. So you're oxidizing the outer chitinous layer for removal. So once it is oxidized, you will see a color change from brown to orange. Once you see this color change, you try to ensure that throughout the entire beaker that you are decapsulating, there is an entire color change or as much as possible. And once that has been done, you're going to rinse again. So you're going to empty it into your brine shrimp net, rinse out the bleach as much as possible, and then you're going to decant or transfer it to a clean beaker of water that will for hatching overnight, and make sure you have constant aeration. Okay, otherwise they're going to die. Okay, so our end product will be what we saw here. So this would have been underneath the dissector microscope. You will have seen the decapsulated brine shrimp as well as the live brine shrimp. Okay, so make sure you'll have a sketch or a picture at least of the decapsulated and the hatched brine shrimp, so you can include that in your results. Any questions? Anybody's confused about anything? So this is mostly a larval feed for small organisms.
What's the proper name of the author there?
Chitinous. C-H-I-T-O-N-O-S.
C-H-I.
Chitinous, right? Now the brine shrimp, it's Artemia, A-R-T-E-M-I-A-S-P, because there are a lot of different species.
Can you spell it?
A-R-T-E-M-I-A, that's your first name, and S, you just want to put S-P dot because there are many different species that can be used.